Hello, hi. My name is Nur Atira binti Raza, WQD 170072. So here in Milestone 5 is more about communication of insight of data. So in this project I will using and then I will show you how I'm using k-mean clustering algorithm and segmentation analysis by using the enterprise miner. Okay, so here my final process flow diagram where I import my data set here and then I do filtering and then I create clustering and also I need connect with the segment profile. Okay, about the filtering. Filtering, we need to remove unwanted information or data that we don't want to use in this project. And then clustering, we need to connect with the filtering because we want to rule or we want to create of the algorithm. Then we want to know what the segment analysis for the our data source. Okay, so let me explain you one by one. Okay, so next. Okay, after we import our data set here, we need to explore the data. Means that we need to explore our data set here. Okay, here our data source explore. So as you can see here, we have our variable close, date, height, open, stop, adjustment, close, counter, difference, low, target, and volume. So under this data source, I set stop and also counter as a rejected. Mean I don't want to use this variable. Then I explore this data set. Okay, so here the explore window for the each data for the variable. So for the sample properties, you can see here for row we have 16338 and for the column we have 11 column and library under AAEM61. And for member I use EM save F3. Okay, so here histogram for the date, height, hook, open, adjustment close, different, low, target, and also volume. So I want to explain more about the adjustment close. Okay, so here, for the adjustment close histogram, as you can see here. Sorry, I cannot work my cursor. Okay, as you can see here, at the above we have at the left for the currency we have 1,000, 50,000, and then for the adjustment we have the highest one on 0.02020 and the lowest one here 103.200. Okay. Then I want to change here. I want to use property histogram and change the number of bin X to the 100. So I set for this one to the 100 bit. So let's see what happened. Okay, so here from here base here, so it's been divided in small pieces to here. So here the highest one and here the lowest one. Okay, for the adjustment close, so I click here. We have 0.02 until 1.0517999969, and for the current frequency 8689. So means that is great, it's high level. So here, okay, after we connect the our data set to the filtering, we need to change default filtering method to user specific limit And then after we set here, we need to click three dot here for interval variable. After we click here, we can get this one. Okay, under this one, I want to use adjustment clause where I need to set 0.1 size for the adjustment clause. Then for this one, 0.1 will be filtered. Means for each size must be less than 0.1 and it will be filtered. And then after that, I run the result and then I got this one. Okay, as you can see here, for the data role train variable, I choose adjustment clause. And then for the statistic, no missing. For the original, I got 15960. And then for filtering, 15383. It means that it's more or less than from the original filtering. After we do filtering, it will delete unwanted whatever that we don't want to use. Okay, so missing value still remain the same, and then maximum from 0.02, and then we got 0.10, and then for the maximum still remain same, and for mean is changed a bit, and then for standard deviation also skewness kurtoise also change. And as you can see here, for data role train variable to target, and then non-missing value is repeat a change. Same with this one. Okay, and then we got -1 for the kurtoise, negative 0.15, and then under filtered we got negative 0.16. This means good news for us. So now our data ready for the segmentation. Okay, to be more meaningful for the segmentation, we need to ignore the irrelevant input and standardize the input, and then we need to standardize the input. Okay, for the cluster node, under the cluster node, we need to create segment by using the close. Okay, I want to use close, high, open, difference, low, and volume. So I set as a default, and then stock and also counter I don't want to use, and adjustment clause I want to use. So after the explore, so here the result, the input selected. Okay, all the result here is very different because it depend on the input selected, and then the difference measurement scale we need to standardize to get the more meaningful clustering. After we run the cluster node, we got this result. Okay, this one for segment plot. So we can see for the close, high, and open, we contain colorful colorful record. So for the segment size, I put for 12. So here the our segment size by using pie chart, and also this one for output and for main statistic. So as you can see, clustering criterion is remain same, and also same also with the maximum relative change in cluster set. Okay, so I want to explain a bit about the segment analysis, segment size for the pie chart. So I click here for the 8 segment ID 8, and then for the frequency of cluster we have 1913 peak. So for the CC plot also, as we can see here, it remain to increase first and decrease, also it decrease and keep slowly is increase and going down again and slowly increase increase and until the maximum point. Okay, so I put the cursor here. The number of clustering is 90 and cubic clustering criterion is around 463.1911. Means it's getting increased by number of cluster. When cluster 20, number of cluster is 20, is 20 here, is keep increase, and if after the number of cluster is 30 also increase, and the number of cluster 50 also increase until the maximum point. The number of cluster in a data set is regulated by the peak of the CCC plot versus number of the cluster plot. So we also can change here. We also can change the number, the peak of the CCB versus the number of cluster plot by using. Okay. We also can increase the number of cluster by changing. Okay, means that we can change the CCCS by cutoff property or by specifying the desired number of cluster. Okay, so under the properties panel, we need to select specification method to user specific here. So after we change everything here, we need to write it here and then we need to run. After the running process, it maybe take a few seconds, around 6 seconds or 10 seconds, maybe 1 minute, depend on our data. If our data too big, maybe take a time more longer. So after the run, so here we get the result. So as you can see here for the mean statistic, for the clustering criterion, we get a same value for 10 clustering. We get a same value, segment ID 1 until 10, which means 10 clustering we use. 10 clustering number we use. Okay, for the clustering criterion is remain the same. Also for the maximum relative change in cluster seeds also remain the same. Okay, so frequency of cluster is little bit changed here. So the highest one is for under frequency of cluster 14698. Okay, so its number for nearest clustering also for the sevens. Okay, so for the lowest one, we can say it's mean for 2 frequency of clustering. Okay, next. Okay, so I want to explore for the train result. This result will show the data set that are generated and explored by cluster node. And then after I will select train under port here, and then we click on the explore, then this result will pop up. And then so here all the data from train, so that one we can explore all the result from the train. And then for the role unknown column 14 and then random we set a sample method, we set a random, and feature size we set as a maximum. Then so everything as we can see here, the date and the order counter is keep same. Okay. Okay. Okay, so now from here, from the explore train, I want to use a multiple plot. First, I want to use a scatter plot, where for the adjustment close, we can see here this one versus with the distance. So it's keep running away. So it's not like standardized and it's keeping distributed in many places based on the adjustment clause value. For example, here 100, as you can see here, for distance 10. So second, I want to use scatter plot in 3 dimension, where I compare with the counter, adjustment clause, and also distance there. So if distance is more to far from the counter and adjustment clause, you can see it's more to dark here. And then the distance between each other is too crowded. And then as you can see here, if difference 10 and then adjustment clause around 0 or 25, so the spacing between this one cluster is remain a space between each other, so it's good for our project here. So now I want to use a histogram plot under segment. Okay, so here I use a segment ID, and then I versus with the frequency. So the highest one from 8.2 for the adjustment close and until 9.1, and we got frequency around 14698. So it's remain the increase level here. So now we want to use after we run the clustering and we connect with each other. So now we will use the segment profile, where we can compare the distributed of the variable in an individual segment to distributed the variable overall, and then we connect cluster node and segment profile node. So we connect here. After we connect, we need to run here. Right click and then click run. So here the result of the segment. So means this one the final result after we do k-mean, clustering and everything. We put the filtering and so on. So here we have 3 segment 9, 7 and other. As first we look under segment 7, when we have a count 494 and percentage we got 3.13, is a bit lower. Okay, so for the adjustment clause, this one, the blue color is the original one, and then the magenta color is like two new data. So as you can see here, around here, from the original, we got highest, more than highest, we got highest, but suddenly it's going to lower here, so we can compare from the distance. From the distance, as you can see, from the lower, it's getting lower, and then it's high again, and then for the close, it also is remain the same. Increase here. So we compare from segment others. We counter, we have 5969 between segment 7. We can see here is getting increased. Okay, the blue one is the old data, and then this one, the increased one, is going to increase. And then as you can see also in the segment 9, we got a count 140,698. We got increase. Yeah, so this one for the adjustment also is getting increased. Everything is getting increased. So for the height under segment 7 is getting lower, but under segment others is also remain same, and then here is getting increased. So here the my result from the k-means clustering algorithm and also segmentation analysis. Okay, that's all from me. Thank you.